So let's try the January 2023 paper for the maths Edexcel S1 paper. All right. So the histogram shows the time taken t minutes by each of the 100 people to swim 500 meters. Use the histogram to complete the frequency table for the times taken by 100 people to swim 500 meters. Okay, so in the frequency density, histograms basically, the area of this bar represents the frequency. So area represents the frequency over here, and that is equal to frequency density times by the class width. Okay, so we know the widths over here, but we don't know what the frequency densities for each of these bars. So let's figure these out. So we know that frequency density is equal to frequency over class width. So we just need to, figure these out. So let's make a row for frequency density also over here. Okay, so for this one we have 10 over 5, 10 minus 5, then 16 over 4, and then 24 divided by 4 also. So 10 divided by 5, 2, 16 divided by 4, 4, and 4 times by 6. Right, so let's see what these mean. So this is 2, this is 4, this is 6. So that means this represents 1 unit. So this means that the height of this bar is 5. So this would be area or frequency would be 5 times by 25 minus 18. Okay, similarly for this one, the frequency would be will be equal to 1 times by 25 to 40. Okay, so class width 40 minus 25. Okay, so now we have 25 minus 18 times by 5, which is 35. And then 40 minus 25, which is going to be 15, like that. Okay. Estimate the number of people who took less than 16 minutes to swim 500 meters. So 16 is in this class over here, 14 to 18. Okay, so halfway between this. Okay, so halfway basically means halfway. So we will have to cut this a rectangle in half. So we will only take the area of this half over here. So basically half of the area of this. Okay, so this will be our estimation. Okay, so the frequency in this, and only half the frequency in this. So 10, 16, and 12. So B would be 10, 16, 12. 10, 16, 12. 38. Okay. Find an estimate for the mean time taken to swim 500 meters. Okay, so what we will do over here, we will take the mean values of these classes and then multiply each with their frequencies. So the process for it's very straightforward. We will have sum of frequency times by x divided by sum of all frequencies. But these x values represent the mean points of these class intervals. So 7.5 times by 10. Okay. Then we have 12 and 16. Plus 16 and 24 plus 18 minus 25 and 18, so 25 minus 18, sorry, no, no, average, so 18 plus 25 divided by 2, that is 21.5 times by 35 plus we have right frequency. Oh no, sorry. Oh no, right. That was fine. Sorry. 15 times by 40 plus 25 divided by 2 average. That is 32.5 times by 50. Okay. Now divided by the complete frequency, which was 100 people. All in the calculator. So 7.5 times by 10 is 75 plus 12 times by 16 plus 16 times by 24 plus 21.5 times by 35 and then 32.5 times by 15, just to make sure that we have the same thing. Okay. Wait. Oh, this is plus. Sorry, plus 1891. So the mean would come out to be 18.9. Right. Okay. Given that sigma ft squared is 41033, find an estimate for the standard deviation of the times taken to swim 500 meters. Okay, so by the way, sorry, I meant to take this was times, so this is going to be time and time. Okay. So for the standard deviation, let's start with the variance first. So variance would be ft squared divided by n minus the ft divided by sigma f whole squared, or in short, the square of the mean. So they gave us 41033 divided by n was 100 minus 18.91 whole square. So 41033 divided by 100 minus 18.91 whole square. We get this, and 52.7419. We square root this, we get 7.26. Right, okay. Then we, given that upper quartile, so Q3 means upper quartile is 23. Use linear interpolation to estimate the interquartile range of the times taken to swim 500 meters. Okay, so basically means we need to figure out where the upper quartile is, right? So upper quartile is at 25% of the total frequency. So that's at 25. So let's see where the 25 adds up from the start. So 10 plus 16, the total over here adds up to 26. So this means that 25 is in this class over here. So let's make a line for this to understand what the case is. Oh, sorry. The class is from 10 to 14. Somewhere over here is our lower quartile. It's the class frequency starts from 10 to 26. Okay, all right. So now finding the Q1 is easy. So because Q1 minus 10 divided by 14 minus 10 equals to 25 minus 10 divided by 26 minus 10. So let's simplify this before we go on. So this is Q1 is equal to 10 plus 25 minus 10 is 15, 26 over minus 10 is 16, and then times by 4. So 10 plus 15 times by 4 divided by 16. This comes out to be 13.75. So IQR, the quartile range, is basically the difference between upper quartile and lower quartile. So upper quartile, they gave us 23. Lower quartile, we just figured out. So 23 minus 13.75. That is 9.25. Okay, so straightforward. Okay, moving on to next question. So two bags X and Y each contain green marbles and blue marbles only. Okay, bag X contains 5 green marbles, 4 blue marbles. Bag Y contains 6 green marbles, 5 blue marbles. Okay, a marble is selected at random from bag X, placed in bag Y. Okay, second marble is selected at random from bag X and then placed in bag Y. Third marble is then selected this time from bag Y. Okay, so that means after so at the time of third try, the number of total marbles in bag Y will increase by 2. Use this information to complete the tree diagram shown on page 7. Okay, so let's first write. Oh, actually, they have actually given us 5 over 9 and 4 over 9. But this is from the bag X. Okay, so initially, let's record the bag Y also. Bag Y had initially 6 green and 5 blue marbles. So 6 greens, 5 blue marbles. Okay, all right. Right. So, okay, so they have given us the first thing. Okay. So when 2 greens have been chosen and then placed in the bag Y, so choosing a green from the bag Y will increase by 2. So the total number will increase by 2. So there were 6 in total. So they will now increase to 8. And previously 6 plus 5, 11. Now they will climb to 13. Similarly, the blue balls will remain the same because the blue balls were not added, but still the total number increases to 13. Now, if the green ball was selected and then blue ball was selected again from the bag X, that means again divide by 13, divide by 13. But the probability of getting a green ball is just 7 over 13. And since one blue ball is added, so that's 6 over 13. Similarly, if a blue ball is first chosen, so that means green remains 5 or 8. But the probability of choosing a blue again drops to 3 over 8. Actually increases to 3 by 8. Sorry. So now when we have chosen blue, green, okay, the probability of getting green from the bag Y is basically very similar to the green blue case over here. Okay, so that's 7. No, wait, hold on. No. Green ball has increased. So green previously was, so they have 7. And then one blue ball was increased. So that means this becomes 6. Right, okay. So we have completed the tree diagram. Find the probability that 2 marbles selected from bag X are of different colors. Okay, all right. So different colors means these two scenarios, basically. These two scenarios. So 5 over 9 times by 4 over 8. Actually, you will add you can multiply these two also, but they will, just sum up to 1. So we are actually just dealing with these two things. 5 times by 4, 9 times by 8. Actually, these are identical. So B part is 5 times by 4, 9 times by 8 times by, sorry, this is squared. Okay. No, sorry, times by 2, sorry, times by 2. Because this is an OR case. So 5 and 4 and 9 and 8 in the denominators. Okay, yeah, so this is an OR case. So 5 times by 4 times by 2 divided by 9 divided by 8, that is 5 over 9. Okay, find the probability that all the 3 marbles selected are the same color. Okay, so all the 3 marbles selected in the same color. So, we will have green, green, green. We have blue, blue. So 5, 4, 8, 9, 8, 13. 5, 4, 8, 9, 8, 13 plus 4, 3, 7, 9, 8, 13. So just the numerators 4, 3, 7 and 9, 8, 13. 4, 3, 7, 9, 8, 13. So denominators are same. So 5 times by 4 times by 8 plus 4 times by 3 times by 7 divided by 9 times by 8 times by 13. 61 over 234. Okay, given that, okay, now this is the conditional state. Given that all the 3 marbles selected are the same color, find the probability that they are all green. Okay, so out of these case over here, we just have to select all the green. So probability of all the green divided by the total same color. So probability all green, G, 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 same color. So G, G, G and same color is basically the same thing. So G, G, same event. There's no thing. G, G, G's are all the same color anyway. And then probability of same color. So G, G, G is basically this. So 5, 4, 8, 9, 8, 13 divided by 61 over 234. So 5 times by 4 times by 8 divided by 9 divided by 8 divided by 13, that is 2117 times by 234 divided by 61. So times by 234 divided by 61. So 40 over 61. Right, this was straightforward. Okay, moving on to the next question, number 3. The probability distribution of the discrete random variable x is given by, where a is a constant. Find in terms of a the expectation of x. Okay, right. Okay. So e of x can be written as this multiplied by this, this multiplied by this, this multiplied by this, and then added up together. So 2 times by a plus 3 times by 0.4 plus 4 times by 0.6 minus a. So 2a 1.2 plus 2.4 minus 4a. Just to confirm that I'm right, 3 times by 0.4, 1 over 2, and then 4 times by 0.6, 2.4. Okay, so this becomes 2.4 plus 1.2 adds up to 3.6 minus 4a plus 2a is minus 2. Okay. Find the range of possible values of x. Range of possible values of x. Okay. Now, first off, it cannot be, less than 2, greater than 4. Okay, but let's see this condition over here to figure out the exact thing. So we know that sum of all the probabilities added up adds to 1. So a plus 0.4 plus 0.6 minus a should be equal to 1. And obviously we are seeing that this is, indeed it is the case. However, if a is 0, can a be 0? If this is 0, for example, then this becomes 0.6. Okay, so the minimum value, obviously we can go to that. So we can definitely have it. So 0.6 minus 0, so this would time to that. So yes, that is possible. 0 is the minimum value of a. Obviously a is the probability, so the minimum value is going to be, at least we have to consider 0. Now the maximum value. Maximum value obviously cannot exceed 1, but obviously 0.6 minus 1 cannot be right. Over here, this is also probability, so the minimum we can get, minus a, is minimum we can get is 0. This would mean that a is 0.6, and this would become 0.6. So yes, that's the maximum value, 0.6. Now, if this is the case, we need the range. So if a is this, then minus 2a, or just 2a, would be multiplying with both sides, 0, 1.2. When we turn it minus, then minus 2a, it will become minus 1.2, 20, and then add 3.6, sorry, 3.6, minus 1.2, 3.6 minus 2a, 3.6. So this 3.6 minus 1.2 is 2.4, less than 3.6 minus 2a, less than 3.6. So this is the range for expectation. Okay, right. Given that the variance of x is 0.56, find the possible values of a. Okay, so we need actually the description for the variance. So variance of x, all the values of the x squared times by the probabilities. We have 2, 3, 4. So 2 squared, so sorry, wait. Ex squared minus the square of e of x. Okay, so e of x squared, we first need to figure out what e of x squared is. So 2 squared times by a plus 3 squared times by 0.4 plus 4 squared times by 0.6 minus a. So 4a plus 9 times by 0.4, which is going to be 3.6. And then we have 16 times by 0.6, 9.6 minus 16a. Right, so let's simplify this. 3.6 plus 9.6. This is 13.2 and then minus 12. So variance of x will be 13.2 minus 12a minus the mean squared. So we actually have to, square this, basically square of this. 3.6 minus, wait, sorry, 2a? Yes, 2a whole square. Okay, so let's expand this. So 3.6 squared is 12.96 minus 3.6 times by 2 times by 2 is 14.4a minus plus 4a squared. So now the signs change, minus, plus, minus, and then we can open the brackets. So now let's simplify this. We have 13.2 minus 12.96. That is equal to 0.24. Then we have 14.4 minus 12. That is 2.4. And then minus 4a squared. They said that the variance is equal to 0.56. Okay, so that means this entire thing goes on this side. So 0.24 minus 0.56. Okay, so this becomes 4a squared minus 2.4a. And when we switch the signs, it will be plus 0.32 equal to 0. Okay, now we just need to solve for a. Wait, do we need to solve for a? Find the possible values of a. Okay, a 2.4 squared plus minus 2.4 minus 4ac, 4 times by 4 times by 0.32. Sorry, b squared. Sorry, this is minus b. And then 2 times by 4, 8. So 2.4 plus minus 2.4 squared minus 16 times by 0.32. That is 0.64. 8. So square root of that is 0.8. So 2.4 plus minus 0.8, 8. So A is either 2.4 plus 0.8 divided by 8, that is 0.4, or A is either 2.4 minus 0.8 divided by 8, that is 0.2. Right, okay, so these are the possible values of, so either 2 over 5 or 1 over 5. Okay, all right, so I think that was the last part. Okay, all right, good. Moving on. In the Venn diagram, A and B represent events and P, Q, R, S are probabilities. Okay. Probability of A is 7 over 25, 1 over 5, and that is 8 over 25. Use algebra to show that 2P plus 2Q plus 2R is equal to 4 over 5. Okay, so first off, all of these will add up equal to 1. Okay, so we know this. This is the first thing we know. P plus Q plus R plus S is going to be 1. Okay, now the probability of A is 7 over 25. Probability of B is 1 over 5. Okay, so let's see what this is all about. From the A and B, we can find out Q, although not directly, but let's try that anyway. But let's try this. So A intersection B complement is A intersection B complement is just P. This part, this is just simply this. Okay, and A complement intersection B is just this. Okay, so basically they have told us the P and R is 8 over 25. So P and R add up to 8 over 25. Okay, so what we need over here, so let's go back over here. So if we see what probability of A means, so probability of A is basically a combination of P plus Q. So, and the probability of B is Q plus R. Okay, so let's see this. So P plus Q and then Q plus R. So P plus Q, they gave us 7 over 25. And Q plus R, they gave us 1 over 5. Okay, so now if we add them all up, we add all of these equations together. So P plus R plus P plus Q plus Q plus R, and then 8 over 25 plus 7 over 25 plus 1 over 5. So when we expand this, you see this becomes 2P plus 2Q plus 2R equals to, now if we want to change the denominator, this is going to be 5 over 25. So divided by 25, and then 8 plus 5 plus 8 13 plus 7, that is 2, wait, if I'm right. No, wait, sorry. 8, 7 plus 5, that is 20. And that is indeed 4 over 5. So that's shown. Okay, find the value of P, the value of Q, and the value of R, and the value of S. Okay, so over here we are going to, use this also. Because now we know what PQR is. Okay, so if we reduce this, this part is now part B. Okay, so this was part A, sorry. Now part B is that using P plus Q plus R is equal to actually 2 over 5 by just simply dividing this equation by 2. Okay. So, and we also know that P plus Q plus R is actually equal to 1 minus S. So using that, we can find out 1 minus S is equal to 2 over 5, and that means S is equal to 1 minus 2 over 5, which is 3 over 5. Okay, now that we found the S, 3 over 5, now let's go back to finding the rest of the values. Okay, now P plus Q plus R represent the union of A and B. So P plus Q plus R is equal to probability of A plus probability of B minus the probability of A intersection B. So probability of A, they gave us 7 over 25 and 1 over 5 minus 1 over 5, and the intersection is actually Q. So P plus Q plus R. Okay, so we have the value of P and R that we calculated, 8 over 25. So we will swap it out over here. So, and then q will be taken on the other side also. So 2q 7. So this fraction, when we convert this into common denominator term over here, that would be 5/25. So 5/25. So so 2/25 minus 8 over, no, wait, sorry, 8/25. This was plus, sorry, my bad, my bad. So this ends up to be 4/25. So q is actually 2/25. Now we have found q, we can find out r from this. So r is going to be 1/5 minus 2/25. So 5/25 minus 2. So that is going to be 3/25. Okay, so P, did we find out what P was? So we have found Q, well, we found R. I think we found Q, we have found R, we have found S. I think only P remains. So for the P, we will use now the 8/25 or the 7/25. So for P, we will use R plus P. That was 8/25. I keep forgetting 8/25. So P will be equal to 8/25 minus 3/25, which is 5/25 or 1/5. So P is 1/5. Therefore, Q is 2/25. R is 3/25. And S is, wait, what did we calculate? 3/5. Right, okay. Right. Two events, C and D, are such that probability of C is equal to x/x plus 5 and probability of D is 5/x, okay, where x is a positive constant. By considering P of C plus P of D, show that C and D cannot be mutually exclusive. Okay, so mutually exclusive cases are those where the C intersection D is actually 0. So we actually have to show that this cannot be 0. Okay, so let's see. Let's see. So what's this part? Second part. So probability of C is x/x plus 5, and probability of D is 5/x. Okay, so if we actually want the union of these things, or sorry, union, we will have the probability of C plus probability of D minus probability of C intersection D. So we don't know anything except the probability of C and D. So that is x/x plus 5 plus 5/x minus probability of C intersection D, and that is equal to that. So this comes out to be x times by x plus 5 x squared plus 5x plus 25, which is, if you, no, okay, so let's see what this how do we actually, sorry, let's see how we actually show that this cannot be 0. So if I convert the denominator over here into the x squared plus 5x. Now we can't cancel out the x squared plus 5x, so don't make that mistake. However, what we can do is we can uh, do the long division a little bit. So we have x squared plus 5x plus 25. We have x squared plus 5x. So 1 x squared plus 5x, we get 25. So 25 is the remainder over here. Okay, so I'll keep this separate in a different color. And then we'll come back to this as 1 plus 25 over x squared plus 5x minus probability of C intersection D. Okay, so if x is a positive constant, therefore this means that x squared plus 5x is a positive constant, right? So therefore this further means that 25 over x squared plus 5x will also be greater than 0. Okay, so therefore when we add this with 25 over x squared plus 5x, this would be greater than 1 at least. Okay, so probability of only this part is exceeding 1. So obviously we will have to bring it down to either less than or equal to 1 through this thing over here. Otherwise it's going out of bounds, impossibility. So without this it cannot be possible. So probability of C plus probability of D is greater than 1. So probability of C uh, can never be 0, otherwise it's an impossibility. Can never be 0. Okay, right. And that was a very interesting over here. Okay, now on to the question number 5. The length L of housefly wings are normally distributed with L tilde m 4.5, 0.4 squared. So 0.4 is the standard deviation. Find the probability that randomly selected housefly has wing length of less than 3.86 millimeters. So basically what we're looking for is probability of length less than 3.86 millimeters. Okay, and we have L normally distributed 4.5, 0.4 square. Okay, so let's copy this and paste it down. Okay, right. So first off, we will need to convert this into a standard normal variable. So probability of Z less than 3.86 minus 4.5 divided by 0.4. So 3.86 minus 4.5, that is this, divided by 0.4, that is minus 1.6. Okay. Now, as we know, before we go into the table, 1.6 is going to be somewhere close to, to the left of 0. Okay, so we can't exactly find this out easily. So what we do, we make this 1.6 positive and the area will be this. However, again, the problem remains the same. So this would be, as we're saying, this is going to be equal to Z greater than positive 1.6. However, To get this, we can just subtract the area less than that from that. So 1 minus, sorry, probability of z less than 1.6. So basically from the table we will be looking for this normal distribution table, and we are looking for less than 1.6. We actually want to do 1 minus probability of z less than 1.6. So this is what we are looking for. So 1.6 first we have to look. 1.60 simply put. This is that 0.9452. So 1 minus 0.9452 is our answer. 0.0548. Sorry, 1 minus 0.9452 equals to 0.0548. So 0.055 is also correct. Even if you write 548, that is also fine. Okay. Find the upper quartile of L. Basically, when the area adds up to accumulates up to 0.25 and 0.5. So the beauty of the normal curve and the standard normal curve is that they will correspond to the same value but negative and positive. So this will be, for example, A. This will be A. Finding the method will be exactly similar. So once we find the upper quartile, finding the lower quartile will be easy. Okay. So B part 1. So Q3 will correspond to probability of L less than Q3 equal to 0.75. So that will correspond to Z less than some, let's say Q3 equal to 0.75. 0.75. Now we're looking for the probability, not the, now we're looking for the Z value that corresponds to this. Now, if we notice that this is in between these two values, okay, so we will have to figure it out using linear interpolation. Okay, so let's paste it over here. Sorry, just once was enough. Okay, all right. So we need the 0.75. So we will do the same process we do for that. So Q3 minus 0.67. Although it's not a linear function, but we can, perform a little bit of linear interpolation on this. So 0.68 minus 0.67 equals to 0.75 minus 0.7486 divided by 0.7517 minus 0.7486. Okay, so 0.67 plus, sorry, so we have 0.75 minus 0.7486 divided by 0.7517 minus 0.7486. That is 14 over 31 times by 0.01 plus 0.67. Okay, so answer times by 0.01 plus 0.67. So that is going to be 0.6745. Okay, now Q3 is the value 0.6745. So Z value Q3 would be minus 4.5 over 0.4, yes, equals to 0.6745. So Q3 would correspond to 0.4 times by 0.6745 plus 4.5. So answer times by 0.4 plus 4.5. That is equal to 4.76 or 77, let's say. Okay. Now, the same value that we found could be applied for the lower quartile also. So Q1, so probability of L less than Q1, probability of Z less than Q1. So Q1 is negative of this value, this, then answer times by this. We get 0.6745 again, right? So negative of this answer is this, okay? So minus 6745. So now we're going to use for the Q1 minus 4.5 divided by 0.4, minus 0.6745. So Q1 is going to be equal to 0.4 times by minus 0.6745 plus 4.5 times by 0.4 plus 4.5, that is 4.23. So that's that. So Q1, therefore, lower quartile 4.23, upper quartile is 4.77. Okay, all right, moving on. A value that is greater than Q3 plus 1.5 times by Q3 minus Q1 or smaller than this is defined as an outlier. Find these two outer limits. Okay, in terms of the L. Okay, so that's the simple, sorry. Which part was it, sorry? C part. Okay, so Q3 plus 1.5 times by Q3 minus Q1. That's what it said, right? Right. Okay. Okay, so this is the upper limit. Sorry, I forgot to write the upper limit. So Q3 is 4.77 plus 1.5 times by 4.77 minus 4.23. That is 5.58. Now the lower limit, Q1 minus 1.5, Q3 minus Q1 is minus and then 3.42. This is the lower limit. Okay, right, moving on. A housefly is selected at random using standardization. Show that the probability that this housefly is not an outlier is 0.993. Not an outlier. Okay, so basically this means that this is, let's call this LU, let's call that LL. Lower limit, upper limit. Okay, so basically in between these limits over here. So probability that it's in between lower limit and upper limit. We actually have to show that. Okay, using standardization. Okay. So this would be equal to, lower limit is 3.42. So 3.42 minus 4.5 over 0.4 z. The upper limit was 5.58 minus 4.5, 0.4. So 3.42 minus 4.5 divided by 0.4. That is minus 2.7. That is 5.58. Positive 2.7. So basically what it will come out to be is 2 times by probability of z less than 2.7 minus 1. Because you see these are identical values over here. Minus 2.7, 2.7. So we just need to find out what's the value of 2.7. 2.7, and that's over here. 0.9965. So 2 times by 0.9965 minus 1. And that's 11. So 2 times by 0.9965 minus 1 is equal to 0.993, as what we needed to show. Okay, given that this housefly is not an outlier, so that means this is now the given condition, conditional state. Showing your working, find the probability that the wing length of this housefly is greater than 5 millimeters. Okay, so greater than 5 millimeters, length greater than 5 millimeters, and this is not an outlier. This is not an outlier. Okay, so that's in between this limit. Okay. So L greater than 5, given that not outlier. Or we can actually say that it lies between 3.42 and 5.58. So 3.42 L, whatever this is, 4.5. Oh, sorry, 5.58. Okay. So basically, we need the probability of 5 less than 5.58 divided by the probability of 3.42 from L, sorry, less than L less than 5.58. Okay, so this is what we need to find out. So the numerator is what we need to find out. This we already have. Okay, so this is what we need to find out. So the probability of 5 L greater than 5 to 5.58 is basically probability of L less than 5.58 minus probability of less than 5. So we already know this that corresponds to 2.7, z less than 2.7 minus L less than 5, z less than 5 minus 4.5 divided by 0.4. So z less than 2.7, we actually found it to be 9965 minus, this is what we have to find out. This is, sorry, 0.5 divided by 0.4, 1.25. Okay, so we go back to the table, 8944. So 9965, 8944. So 0.9965 minus 0.8944, that is 0.1021. Now when we put this probability over here, the conditional probability, so probability L greater than 5 between not outlier, that is going to be equal to 0.01021 divided by 9965, oh no, 993. That is 0.103. So we can also write it as 28 here. Or 103 was also sufficient. Right, okay, so that was the question number 5. Okay, next step is question number 6. Okay, a research student is investigating the maximum weight, y grams, of sugar that will dissolve in 100 grams of water at various temperatures. The research student calculated the regression line of y on x to be this, okay? Give an interpretation of the gradient of the regression line. So basically this is giving us the rate of change basically, right? So this is in y grams, right? So for each additional rise in temperature, 2.72 extra grams of sugar can be dissolved in water. So we will say for each unit Celsius rise in temperature, additional 2.72 grams of sugar can be dissolved in 100 grams of water. 2.7, right. Use the regression line to estimate the maximum weight of the sugar that will dissolve in 100 grams of water when the temperature is 90 degrees Celsius. So basically 151.2 plus 2.72 times by 90. Oh, 2.70. 396. So y equals to 151.2 plus 2.72 times by 90, that is 396 grams. Okay, comment on the reliability of the estimate, giving a reason for your answer. So 90 degrees Celsius is outside of this range. So this is an extrapolation, so it's not reliable. So estimate is not reliable as it was an extrapolation, sorry, of the model, as 90 degrees is outside of the data for temperature, which is between 10 to, wait, sorry, what was it? 10 to 80. Okay, all right. Using the regression line of y on x and the following summary statistics show that the product moment correlation coefficient for these data is 0.98823 decimal places. Okay, so product moment correlation coefficient, that is equal to SXY divided by SXSY. Now, how do we know what Sx is? So Sx is the square root of Sxx, and the Sy is equal to the square root of Syy. Okay, so we need to find both of them first. So let's just quickly paste that information that we had. So okay, right. So we don't have the sigma x, so we can't start out with that. So we'll deal with it later. So Syy is going to be equal to sigma y squared minus sigma x whole squared. Sorry, no, y divided by 12. So 851,093 minus 3119 squared divided by 12. So 851,093 minus 3119 whole square divided by 12. So that is equal to 40412.91667. So that's so let's find out the Sy right from over here. So we actually just square root this. Zero two nine 6413. Okay, so to find out the SXX, we actually need the mean or the sigma x first. We don't have that, right? So what we can do is we can use the equation that they gave us for that purpose. Okay, so y is equal to 151.2. Let's quickly write it over here also. Plus 2.72x. Was it plus or minus? Plus. Okay, we know that this is our, sorry, a plus bx. B is represented by sxy over sxx, right? So sxy we will find out from this. But how do we get the sxx? How do we get the mean of x? So we know that when we have this equation where you can repurpose it to allow for the mean also. So y bar will be equal to 151.2 plus 2.72 x bar. So sigma y over n is equal to 151.2 plus 2.72 sigma x over n. Okay, so sigma y over y we know. Wait, sorry, we had this. So 3119 151.2 plus 2.72 sigma x divided by 12. Okay, so that means that sigma x is going to be equal to 3119 divided by 12 minus 151.2 times by 12 over 2.72. Right. So 3119 divided by 12 minus 151.2 times by 12 divided by 2.72. That is equal to 470, sorry, wait, hold on. 479.632352.9. So obviously that means the x bar, sigma x over n, wait, hold on. Let's find out the SXX sigma x squared minus sigma x over n. No, whole square divided by n. So sigma x squared, they give us 24,500 minus this value, sigma x divided by 12 whole square. So we square this value divided by 12, and then we do 24,500 minus answer. That is equal to 5329.400501. So Sx is going to be equal to square root of this 73.00274311. Right, okay. Now we need the Sxy, capital Sxy, that we will get from the 2.72, right? Because this divided by Sxx is equal to b, which is 2.72. Okay, so Sxy is equals to 2.72 times by Sxx, which is 5329.400501. So when we have this answer 5329.400501 times by 2.72, that is 14495.96936. Okay, so the PMCC is finally going to be equal to Sxy divided by Sx Sy. So Sxy is this 14495.96936. Small x Sx is 73.00274311 times by Sy, that is this value. I'm just copy paste this over here. Right. So divided by divided by 73.00274311 divided by 01.029641. That is 0.988, because they said 3 decimal places. Okay, all right. Okay, the research student supervisor plotted the original data on a scatter diagram shown on page 23 with reference to both scatter diagram and the correlation coefficient. Discuss the suitability of a linear regression model to describe the relationship between x and y. Okay, so let's see what is on page 23. Okay, so our equation, the linear model, was starting from 151.2. Okay, so generally we don't have to make that. So roughly, sorry, let's do the color, and let's adjust it so that it does look like a best fit line. So yes, the points are close to the predicted model line or regression line. So, and the PMCC is also close to 1. So that's why it is suitable. Yes. So the regression line is close to all the points, and the PMCC is close to 1. Therefore, the model represents the relationship between x and y suitably. Okay. All right. And that's about it for the paper. All right. So hopefully see you in the next paper. Bye bye.